Welcome to the video on problem solving exercises. Here we will apply the optimization techniques which we are going over, and I will start with an example of revenue maximization. So let's have the information that the inverse demand function is given by P equal to 100 minus 2Q. With this inverse demand function, I can find out the total revenue to be equal to price times the quantity. I have been given price to be 100 minus 2Q. I multiply Q to this term and I get the total revenue. We can expand the terms in the parentheses. So 100 multiplied by Q. I have to multiply each term in the parentheses with term Q minus 2Q times Q, and that gives me 100Q minus 2Q square. That's the total revenue. So this is what we want to maximize, and now I will write down the optimization exercise formally. So our problem is maximize the total revenue, which is a function of quantity 100Q minus 2Q square, and obviously we are looking at positive quantities. I will make it a little bit more precise. I will say non-negative quantities. So this is the formal description of an optimization exercise. Here we will say objective function is the function which we want to maximize 100Q minus 2Q square. And then the choice variable, the variable which we want to change the values, is Q. And I know it is non-negative. Then we want to see how we will use calculus techniques to find the solution. And we have learned that if the total revenue is maximized at some quantity, let's say positive, then we know that the first order condition very soon I will start writing it as FOC holds, and the first order condition in our situation is the derivative of the total revenue with respect to Q that must be equal to 0. So this is the first order condition. Let me say I will keep writing it as FOC very soon, so I want to write it here as well. So I have the total revenue given as 100Q minus 2Q square. So I will use this to find out the derivative. Derivative of 100 times Q is 100 minus the derivative of 2 times Q square. So it's 2 times 2 times Q to the power 2 minus 1. And this expression must be equal to 0. This is the first order condition. So let's simplify. I get 100 by itself. 2 times 2 is 4. Q to the power 2 minus 1 is Q to the power 1. But we don't write power 1. So I have 100 minus 4Q equal to 0. This is one equation, one unknown. We can solve. So I take the negative 4Q to the other side will go as positive 4Q. I will divide both sides by 4, I get 100 over 4 to be 25. On the right hand side, I get Q by itself. So I know the solution Q star is equal to 25. I got only one solution to the first order condition. So this is the output where the total revenue will be maximized. Let's find out the total revenue. So I can go back to the inverse demand. P is equal to 100 minus 2 times Q. 100 minus 2 times 25 gives me 100 minus 50, 50. That's the price. And then, so I will call P star. This is the price which the firm will set to sell in order to sell 25 units. And the total revenue is price times quantity. So I have 50 here times 25, 1250. So that's the solution. So total revenue, I will call this the star because that's the maximum revenue this firm can earn by setting price equal to $50 and selling quantity. I am putting star everywhere, 25 minutes. And that's a good point to stop.